Hi, in this video we'll be talking about the generic constraints in C#. By default, a type parameter can be replaced with any type. However, it is possible to enforce certain restrictions on the type argument by using constraints on the type parameter. But first, let's do a bit of a setup before we explain how the constraints can be used. I'll create an abstract class called geometric shape. I'll also create an interface called IAreaCalculable and declare a method calculateArea inside it that will return a double. Now I'm going to force this class to abstractly implement this interface. And I will create two additional classes, a square and a rectangle, that will both inherit from the base shape class. They have to implement the calculateArea method, and for the square it is its side powered to 2, so it will have a side property of a type double. For the rectangle, it's the width times height, so it will have these two double properties as well. Now, if I wanted to create a generic method that wouldn't accept just any type, but only the types that are the instances of the class shape, I could write something like this. I'll create a method that accepts the generic type t and returns a double. And I'm gonna name it area multiplier. And just return 0 to prevent the compiler error for now. So in order to restrict the range of the types that could be used as types for this method, I could add the keyword where and indicate that the type t must be an instance of a shape. In the method body, we could return the multiplication action between the area that is extracted from the type and the double multiplier. If I create an instance of a square in the main program and run the multiplier method, we'll get an output as expected. The same would work for the rectangle. But if I create a new class line and make it implement the calculateArea method, but just throw an exception here because the line isn't a two-dimension geometric shape, and create an instance in the main program and call the generic method there, it will of course fail and throw an exception. So we need to apply better restrictions for our generic method. I'll do a bit of a refactoring here and make the shape class a bit more flexible. I'll remove the IAreaCalculable interface and calculateArea from it. You can define some other meaningful fields and methods here. I'll then change the rectangle and square classes to implement this new interface. I have to remove the override keyword because we are not overriding anymore. And I could remove the calculateArea from the line class completely. So now the generic constraint is no longer valid, so I have to adjust the type t where clause. And this time I will use the IAreaCalculable instead. This time I get a compilation error, and it is clear now that the instances of a line type cannot be used as parameters of the area multiplier method. When I run the code again, I get the same results as before when we used to use the abstract class. That was it for this video. Thank you for watching.